All right, let's consider the following equation here. X squared plus 3x plus 7 equals 0. So it's a quadratic equation because my highest exponent is 2. And I see that as a trinomial because there are 3 terms on the same side of the equal sign. So normally, in order to graph this or solve this, we find there's different methods that we've learned. There's factoring, completing the square, quadratic formula, just getting x by itself and with square roots. So let's go ahead and take a look at this. So usually when I see a trinomial, let's try factoring. So 7 on top, 3 on the bottom. And is there a combination that works to multiply to give me 7, but add to give me 3? And without much effort, I bet you could say, actually, there's nothing. Okay, so we can factor this. Let's try completing the square. So half of b is 3 over 2, which is 1.5. So maybe completing the square isn't the best. You could complete the square if you wanted to, but working with fractions, the decimals completing the square, it doesn't really work that well. So something that will always work for trinomials, quadratic formula. So a equals 1, b equals 3, c equals 7. Let's plug it all in. So negative b, which would become negative 3, plus or minus the square root of 3 squared, minus 4 times 1 times 7, all over 2 times 1. All right, let's reduce and simplify. Negative 3 plus or minus the square root of 9 minus. So negative 4 times 1 is negative 4. Negative 4 times 7 is negative 28. All over 2 times 1, which is 2. Now, here's where I bet you guys are freaking out a little bit. 9 minus 28 is negative 19. And we've already talked about, negatives inside the square root. What do? Well, this is how we do it. At this point, we realize there are no real solutions, meaning that when I graph this or when I try to solve this, that there won't be any numbers that cross the x-axis. What will happen is there are imaginary roots, and so we pull out the negative and change it to an I, meaning it's going to be an imaginary root. And we just follow the same exact principle. So it would be I square root of 19 all over 2. So what does this look like as a graph? Let's go ahead and take a look at the picture. Okay, so notice how I use Wolfram Alpha. That's one of my favorite little search engines, and it does a great job of showing me how to factor an equation or plug it in to show me a picture. So this is what x squared plus 3x plus 7 looks like. Notice I have the x-axis in red. Notice how the graph doesn't touch the x-axis. It doesn't touch it at all. So that means that there are no real roots, there's only imaginary roots. And when we're graphing with real and imaginary things, the x-axis is known as the real axis, and the y-axis is known as the imaginary axis. So we're not necessarily concerned that you know how to graph these kind of equations. We just want you to know that when I have a negative inside the square root, it means that I will not have any x-intercepts. I will have only imaginary intercepts. And so in this case, going back here, if I can scoot back a little bit, it's going to be negative 3 plus or minus I square root of 19 over 2. So those are imaginary roots. So that is how you would factor or solve a quadratic equation, but there's no real roots. These are imaginary roots.